So in our contents, along with the videos and everything else, there's text, our PDF, saving you $80 or however much a hardback would have cost. Python for Fun and Profit. Terry Byers is writing this text, so I'll be using his. So in part 1, we learned the basics of Python, how to install the current version of Python and the interpreter we will be using. All right, so we're going to skip the part about installing. I do want you to read this stuff, but I'm not going to read it all aloud. What it's talking about here is the idea of pseudocode. The idea of pseudocode is you're just creating in English the outline, the recipe that the program is going to follow. And if you took 1113, you have a real good idea of what pseudocode is. Pseudocode is something like this. You want to take two numbers and multiply them by each other. Ask the user for A. Ask the user for B. Set C equal to A times B. Display C. Now, it kind of looks like a programming language, but it's not really. This does not match any specific syntax. And then if we were going to turn this into a computer programming language, Python, for example, it would be up to the programmer to read this pseudocode and to translate it into their heads and then into the screen, what they were typing in. So let's go ahead and write this as a Python programmer. Ask the user for A. Well, there's two ways of asking somebody for information in Python. More than two ways. But you can either do something like this. A is equal to input, and then you ask your question right there. Ask the user for A. Or what is A? Something like that. Or you could separate that into two steps, which would look something like this. Print, what is A? And then A is equal to input. Both of these are totally cool. One is easier to flowchart, but this isn't really a flowcharting class, so we're not going to do much with flowcharting. So whenever we see something that says ask the user for A, we know that it's going to be a two-step process, even if it's just one command. This is known as prompting. We are prompting the user with some text on the screen. It will display what is A, and then it will let the user type in something. The input command manages reading the input from the keyboard and storing it in the A variable. So I'm going to skip the fact that the input function can also display text for right now, so I'm going to delete that. Then I'm going to do the next part. Ask the user for B. Print, what is B? B is equal to input. Now we're going to do a mathematical calculation. C is equal to A times B. The word set is just for, for the humans to read. It's not a computer command. So C is equal to A times B. Now if I type all this into Python starting from here to here, we're going to get a syntax error at this point because these are not numeric values. These are strings. That's kind of the flaw of thinking that you can translate line per line from pseudocode into Python code. So I'm going to have to do something before this line so that A and B are actually numbers rather than just strings. A string is a series of anything. You could put in my Aunt Sally as a string. But we have to turn it into a number so that math can be done on it. Yeah, we could turn it into a float or an int. We'll convert them into floats. But I'm going to go ahead and put my print statement here. Print A times B equals, comma, C, like that. But here's the important step. We have to convert them. So A is equal to float A. B is equal to float B. I'm going to open up idle now and actually type this stuff into it, which you may have already been doing thinking ahead of me. So I'm going to go to the Start menu, load up idle, IDLE, choose the top one. I should just dock idle down to the bottom. Pin to taskbar, pin to start menu. So I load up idle, I do file new. Once I have my blank page, I do save as. And you just need to save it somewhere consistently, preferably to a flash drive, or at least to your desktop and then back it up to the flash drive. There's my scripting folder that I made last time, so I'm going to put it there. And I can't think of a real creative name for this one, so I am just going to call it Jan23, Jan 23. Now I'm going to type this code in that I was working on from over there. Here it is in Notepad, here it is in Python. Print, what is A? It ought to be more, user-friendly. Enter a numeric value, something like that. And A is equal to input. I'm going to pad this out with spaces that are completely unnecessary, except just to make them easier to read. Then print, what is B? B is equal to input. Now we have to do our conversions. A is equal to float A. Float is a function which takes a string, a series of characters that have been typed in or whatever, and converts it to a floating point number, which is a number that supports a decimal point. If we use the letters I and T here rather than float, I and T would make a whole number, a number without a decimal point. And it would crash if we typed in 3.1, because 3.1 cannot fit into an int. So that's why we chose float. And then B is equal to float B. Now let's do our calculation. C is equal to A times B. And then we're going to print our result. Print A times B is equal to, followed by a comma, followed by our C variable. To be good programmers, we are always going to put our names and date and what the program is up at the top in a comment block. So I'm going to scroll back up to the top, and using hashtags for our comments, I'm going to say that I am Jeff Thompson, that this is January 20. You're not going to put my name, you're going to put your name. Jan 23. And simple program to do math. Whatever, that's enough. I wonder if I actually typed this in correctly. It's very rare that you type in a bunch of code and then get it to work the first time. What is A? 100. What is B? 2.5. A times B is equal to 250.0. So miraculously, I didn't have any typos.
How you can have the input statement.
So pseudocode is not a programming language, but it's an informal way of describing the program. In the pseudocode overview that we're being presented, 6 basic computer operations. You can receive information, such as reading from a file, or you can get information, which is another way of receiving, from the keyboard. So your input in this class will pretty much consist of either reading from a file or to accept information from the keyboard, and then you can output information, either write it to a file or display on the screen. Then the computer can do arithmetic. It can put a value into a piece of data, what we do with our variable statements. A is equal to this, B is equal to that. It can compare 2 pieces of information and select one of more alternate actions, an if statement, or it can repeat a group of actions over and over and over. So, rewording them slightly. We're going to say 6 fundamental functions. Why is our font back to being super small? Input. Read from a file or accept from a keyboard. He used the word get, so I will go with that. Then there's output. Write to a file or display to the screen. Then there is our mathematical calculations, which I would call expressions. He called it something slightly differently. What did he call it? He said, perform arithmetic. Then you can store data in a variable, and you can do ifs. You can compare two values. And select one of two alternate actions, and select an action to follow. Or you can loop based on a criteria. How did he say that? Can repeat a group of actions. So if you've taken 1113 or you've taken another programming course, you've seen all of this stuff before. You've seen reading from a file. We did not do very much file I/O in 1113. We will certainly do more in this one. Reading from a keyboard with our input statement. Writing to a file or displaying to the screen with our print statement. Performing arithmetic. A is equal to B times C. Stored data in a variable. So we have sequence, sequential steps, selection steps, and repetition commands. Sequential commands are just commands that go one after the other. And we saw that in our code right here. These are all just sequential commands. They all happen one after the other. Then there's the idea of selection. In our programming, these were the diamonds. These were the if blocks. And then there's the idea of repetition. Repetition is something like a for or a while that repeats over and over. So pseudocode for doing some file input. We're going to open a file, and then if it finds the word foo, we're going to replace that word, foo, with another word. And so the pseudocode at the beginning would look something like this. Open the file. For each line in the file, look for that word. Remove that word when found. And insert the new word when needed. And enclose the file. So there's the word for here, meaning that it is repeating over and over and over. It is doing one of these three things. Sequential, selection, or repetition. Okay, so I want to say that before we talk about symbols and expressions, we need to talk about variables. Variables. They are named places in memory that have a data type and have a value. If we do this, A is equal to 1. A is the name. The type is int. And the value is 1. How do I know that the type is int? Because I could go in to Python. I could do this. A is equal to 1, and then I could write in the words type, parentheses, followed by the name of the variable, and it would tell me that it is an int. And yes, this is an int because it's a whole number. B is equal to 1.0, in which case B is the name. The type is float. I could prove it the same way. I'm not going to take the time. Float means floating point, meaning it's something that supports fractional values. You might think that 1.0 is the same thing as 1 to a computer, but it's not. It's stored in a dramatically different fashion with a mantissa and an exponent and everything. And the value is 1.0. So we've seen two different data types there. We're going to do a third data type, a string. C is equal to hello. So C is the name of the variable. The type is string. And the value is hello. I'll prove that down here. C is equal to hello. And then if I do type followed by C in parentheses, it says that the type of that variable is a string. So that's what a variable is. A variable is a named place in memory that has a data type and has a value. We've seen these three data types already. We've seen ints, we've seen floats, we've seen strings. We're going to tack one more on, Boolean. That's if you just set something equal to true or false. If I come here and I say A is equal to true with a capital T, and then I do type of A, that makes it a bool. So which one of these is used to store a series of characters, like the word hello or my name? Yeah, so that's a series of characters. Which one does true or false values? Yeah, bool. Which one does whole numbers only? Int, yeah. And float stands for floating point, which are numbers with decimal points.
So like in Java, when you want to do like a print statement, why does it have the whole Boolean thing in it?
Well, in Java, a print statement looks like this. Where was I entering? Oh, I guess I've lost it. If I wanted to create a variable in Java to hold my name, well, let's do it in C++ first. It would look like this. String name. Name is equal to, and I would put a word. And then I would print out, system.out, nope, I said I was doing C++, C out name, like that. That's C++. If I was going to do it in Java, slightly different data type, capital S rather than lowercase s. The assignment looks the same, and then the print statement looks completely different. This business with the double arrow in C++ is pretty much restricted to C++. You're not going to see that syntax in a lot of other languages that I know of. And if you're going to do it in Java, in Python, it's simpler. You don't have to declare the data, and then you use the word print. So those are our three different types. We're only learning one of these languages, but it's worth mentioning the others just to do kind of a comparative analysis. In Python, the comment character is a hashtag. In C++ and in Java, it's 2 double slashes. What's the takeaway from this really is that in these languages you have to declare your variable before you can use it. I have to say, oh, by the way, this variable is a string. That means that I can only store character data in it. If I tried to type this, name is equal to 3, that'd be an error. It would not compile. So Java and C++ are both known as strictly typed languages. They're strict about their typing. Once you declare name as a string, you can't put anything else other but strings in it. Python doesn't care. I could turn around and after I've stored my name in it, I could do this. Name is equal to 3, no prob. Name is equal to true, hey, great. Name is equal to new turtle, whatever, you know. So that's because Python is not a strictly typed language. You do not have to type your variables, give them a type before you use them. Python decides what the type of the variable is based on the data that you assign to it. And it's not limited to that. Once you assign a string to it, then you could turn around and assign an integer or a float or a Boolean or whatever into it. So I didn't quite understand your question.
Oh, I had something confused. Never mind. You answered it. I
Okay.
just got confused on the print function.
Okay.
Sorry.
Okay. So computers would not be very useful if all you could do was this. A is equal to 3. You know, B is equal to 10. Instead, we want the ability to do mathematical calculations. Those are what are known as expressions. Expressions are series of variables and constants and arithmetic symbols. So A plus B is an expression. A, all by its lonesome, is an expression. B, all by its lonesome, is an expression. What's a constant? A literal constant is something that you literally typed into the system, like a number. A plus 1, that's a literal. 100. A times B plus 100 times C divided by 3.14. You know, there we go. These are all expressions. An expression can just be a single thing, like a single constant or a single variable, or they can be a whole series of them. As long as the syntax is correct. I can't say A is equal to 101C. You know, that doesn't mean anything to the computer. Am I trying to multiply those? Am I trying to add them? The computer doesn't know, and I don't know either. So they do have to follow, you know, a syntax of sorts. So we have some arithmetic operators. Multiply, divide, add, and subtract. There's exponent, and then there's grouping. And there's one that's not mentioned, which is floor division. So let's do arithmetic operators, which our text here calls calculation symbols. And from grade school, we pretty much know. Multiply. That's the big X, but we don't have an X, so that's the asterisk. I call it times when I'm reading text out because I just want to be able to say this. A is equal to 3 times 4. Rather than say A is equal to 3 multiplied by 4 times asterisk. If I say times, just know that I mean for you to type the asterisk. Addition, the plus sign. Subtraction, the minus sign. Division, a slash. Then there's something called floor division, which you could also call integer division. It rounds its result down. That's 2 slashes. And then there's exponent, which is 2 asterisks. Like if you want to say 3 to the power of 4, that's 3 asterisk 4.
Is modulus considered an operator?
It is, and I don't know why it's not listed here. Thank you for mentioning that. Okay, and then modulus. Those of you who haven't taken another course where modulus has been discovered are going, oh, I don't know what that word means. Anyways, okay, so there's our symbols. All along with, along with parentheses to group statements. How was that phrased here? Yeah, just grouping. And we know what parentheses are. They are the smooth ones, not the angle braces or the square braces. So an expression can be something like this. 3 times 4. A plus 10. 6 to the power of 2. What does that mean? That means 6 times 6. 7 to the power of 3, which means 7 times 7 times 7. 9 floor division 2, which means divide 2 into 9 and then round it down. So that's equal to 4. And you can string these to make longer expressions. You know, just like stringing words together to make a longer sentence. 10 plus 20 divided by 2 plus or minus 100 divided by 5 plus 3 to the power of 2, like that. There we've made a pretty long expression. That's a complex expression. It's a long expression. It has a lot of parts. When you are trying to figure out how an expression is solved, you have to remember the precedence. The precedence is that multiplication and division are done before anything else. Actually, the highest priority one are the parentheses. And then there is exponents. Then you have multiplication and division. Then you have addition and subtraction. And division also means modulus and floor division too. So there's the old mnemonic, PEMDAS. P-E-M-D-A-S. I forget what somebody, please excuse my dear Aunt Sally. So the parentheses are the highest priority. That's the P. Excuse, that's the exponent. My dear, that's the multiplication and division. And also floor division and modulus. And Aunt Sally, addition and subtraction. So if we have this expression and we want to break its pieces down, we're going to look, are there any exponents? Or, excuse me, are there any parentheses? No, there's not, so we don't have to worry about that. But are there any exponents? Those are the next highest priority. Yes, there is. There's one exponent. So what is 3 to the power of 2? What does that mean?
3 times 3.
Yeah, that's 3 times 3, so that's 9. Okay, so we've handled all the parentheses, we've handled all the exponents. Now we need to handle all the multiplication and division. You just do them left or right. I see one here. 20 divided by 2 is 10. $100 divided by 5 is 20. When they are of equal priority, you don't look for first all the multiplication and then the division. You just go left to right looking for multiplication or division. Same for addition and subtraction. Now we're going to go left to right looking for additions or subtractions to perform. So we have 10 plus 10, which is 20, minus 20, which takes us back down to 0, plus 9, so that whole thing evaluates to being 9, which I could not have predicted when I wrote it. I was just making it up. You know, I had no idea what it was going to be. So that is how you solve an expression. Solve an expression using PEMDAS precedence. So open up Notepad or grab out a piece of paper or something and just tell me what these things are equal to. How would I solve the first one? What's the highest precedence thing in here?
Exponent.
Yeah, the multiplication.
Oh, multiplication.
So 3 times 2 is 6, so that's 8 plus 6 is equal to 14. So, somebody walk me through solving the second one.
8 times 3
Is 24.
plus 2 is 26.
Right, so 24 plus 2 is 26. And then these are all the same symbol, so they all have the same precedence, so you just go left to right. 8 times 3 is 24, times 2 is 48. And we could throw in parentheses and stuff like that, but you pretty much get the idea. So first is parentheses, second is exponents, division and multiplication, and modulus. And then addition and subtraction. So we may as well talk about modulus since, and you saw that word pop up again. Modulus means remainder. We did not talk about floor division much, but I told you it's the same division rounded down. If I do this, 9 divided by 3. 9 floor division 3. 9 divided by 3 is what? It's 3. Does it have any remainders? No. So it's just a whole 3. That's it, whole stop. 9 modulus 3. You use the percent sign to mean modulus. It had no remainder. 9 divided by 3 equals 3 with remainder 0. So 9% 3 is equal to 0. 10 modulus 3. 10 divided by 3 is 3.333. But if you round it down, you get 3. And then what was the remainder? Remainder of 1.
Yeah.
So 10 modulus 3 is equal to 1. 25 floor division 5. What's 25 divided by 5? It's 5. Is there any remainder? It's got a remainder of 0. So 25 modulus 5 is equal to 0 because there's no remainder. What about 29 divided by 5? That's still 5. It rounds down to 5, but it had a remainder. It has a remainder of 4. So, got a 5, remainder of 4. So 29 modulus 5 is 4. And we could validate that by going back to the Python shell. I'm going to start a new shell because it's all the way down to the bottom. If you ever get tired of the shell, it's got too much in it, you can just close it and then come back to your menu and click Run Python Shell, and you get a fresh one to work with. So 29% 5, 29 modulus 5 is 4, just like we said. 30 modulus 2. What do you think that's going to be?
0.
It's going to be 0 because any even number modulus 2 is 0 because there's no remainder. 31 modulus 2. Well, any odd number modulus 2 is 1. Because if you divide something by 2, it either divides evenly or it leaves 1 left over. Okay, so along with the expressions and the variables, we need to have the idea of the decision making. The simplest one is the if. I won't say it's the simplest one, it's just kind of like the most primal one. If condition, do something else. If student grade is greater than or equal to 60, print passed. Else, print failed. So that's called selection. That's one of the 6 types that were mentioned up here. We have input, we have output, we have perform arithmetic. In our little bit of code, we did some input. We used the input keyword. We did some output. We used the print word. So I'm going to go ahead and tack on to our notes up here that we use the input function to do that, and to display to the screen we used a print. And now we have talked about arithmetic expressions, and we have been storing stuff in a variable all along. Let's go back and look at our little bit of code here. Here we stored something in a variable. The variable was called A. What did we store in it? The results of the input function. Same thing for B. We called the input function, which read from the keyboard, and the results were stored into B. Then we wanted to turn these strings into numbers, numeric types, floats. So we used the float built-in function, passed into it a string, and whatever came back we stored in A. We assigned to A. We did the same thing for the B variable. This effectively converted the A string into a float A so that we could do some math on it. Just for grins, I want you to see something done. Go back to your Python shell and type this. A is equal to, and then put your name inside quotes. And then do B is equal to A times 2. And then just hit B all by itself and hit enter, and it'll show you the contents of B. Jeff. Whatever you typed in as the value of A, Python, I don't know any other language that does this, but Python has decided that if you use an asterisk, it means repeat that string over and over and over. So if I do this, C is equal to A times 10. Well, what did A equal? A equaled that word Jeff. So now it's going to be that word Jeff repeated 10 times. So if I type C and I hit enter, it repeats it 10 times. That is why we had to use that float command. If we did this, A is equal to 100. B is equal to A times, no, that's not what I wanted to do. A is equal to 100 with quotes around it. And then B is equal to A times 10. We would expect 100 times 10 to be 1,000. But instead it's 100. It's this thing repeated 10 times in a row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's because it's a string. Anytime you use the input call in Python, it returns a string. So we have to not let it do that. It's because it doesn't know this is a number. We have to tell it it's a number, and that's what you use that int or that float command for. So if I wanted to turn that A into a number, I would do A is equal to float A. And then if I do B is equal to B times 10 and print out B again, well, that's a mistake. This should have been B is equal to A times 10. B is equal to A times 10. And then print out B, it's equal to 1,000, which is what we expected. That's why we had to use that float command, because otherwise it's expecting that whatever we typed in to the input was a string. And so when we tried to multiply it, we weren't going to get a valid result. So our selection logic. If condition, do something. That's one form of it. Or then there's if condition, do something else, do something else. This is either do something or nothing. If hungry, eat. There's no else clause, so we're not describing what happens if we're not hungry. If we're not hungry, nothing happens. If it's after midnight, go to bed. Else, play Call of Duty. So if we have an if-else, it's describing two possibilities. An if has also got two possibilities, but the other possibility is just absolutely doing nothing. And we can put that into Java code. You use the word if, and then you give it a condition, but you use lowercase letters rather than uppercase letters, and then you follow your if with a colon. So I'm going to go back to that little program that we had written here, and I'm going to say down here after that print statement, if C is greater than 100, colon, and this is just stupid, but it's to indicate the point, print, wow, that's a big number. Now I'm going to run it. So what is A? What is love? Baby, don't hurt me. No, wait. What is A? It's 20. What is B? It's 2. So 20 times 2 is 40. It didn't do anything down here because the answer was not greater than 100. So I'm going to run it a second time. What is A? 20. What is B? It's 10. A times B is 200. Wow, that's a big number. So we saw an if here. We performed an option there. And if this condition, if this clause here was not true, then nothing happened. It just didn't print anything. But we could put else here and make it do something else if this condition is false. So else print not so big A. Really kind of depends on your units though. You know, 1 ton is still pretty big to us, even if it's not 100 tons. But whatever. So here we go. I run it. What is A? I type in 6. What is B? I type in 2, and it says not so big A because it was 12. So you get the idea of what if-else is. That's like the easiest logic in programming, is just having in your brain that you use the word if followed by an expression. This expression is something that has to evaluate to true or false. That's what's known as a Boolean expression. A Boolean expression is one that after you have done that calculation, it doesn't give you a mathematical answer. It's a logical answer. It's true or false. Is C greater than 100? If it is, that's true. So if this is true, then do whatever came next. Do whatever is indented. Else, do whatever is indented there. So we haven't talked about the repeat statement, but let's look at these other little bits of pseudocode and decide whether we understand what's going on here. If we were given this pseudocode, enter first number, enter second number, add first and second numbers, display the sum. Could you do that? Yeah, that's very similar to the program we just wrote. Add values until a limit is reached. Well, we haven't talked about what repeat means. And as a matter of fact, there is no repeat word in Python. It's while. So I'm going to skip that one. Could we do this one? Average 3 answers. Yeah, average 3 numbers. Enter X, enter Y, enter Z, add X, Y, and Z, display the sum, and divide the sum by 3, why would we not then want to display that result? To me, this is bad pseudocode because we're dividing the sum by 3, but then we don't do anything with it. But I guess that's okay. Finding the average of 10 numbers. This is using a for loop. We haven't talked about for loops, so I'm going to skip that one. So these two, this add 2 numbers and this average 3 numbers, are going to be the ones that I'm going to give us as homework. But I'm going to change them a little bit from the text, because to me the pseudocode ought to tell you what to store the result of that math. So instead of saying add the first and the second numbers, I'm going to say set sum equal to first plus second, and then display the sum. And here we're going to say set sum equal to add a x plus y plus c. And then we're going to say how to calculate the average. Display the sum. And then how do you calculate the average? It's just the sum divided by the number. So set average equal to sum divided by 3. And then display the average.
That's going to be 2 separate.
Yeah, just put it all in the same program though.
Do you want us to use a different variable besides sum since it's already defined?
It won't matter. You can pick a different variable if you want. You can use reuse the same one. Okay, so write a program that performs these steps. Now in my pseudocode I had the word display and stuff like that. You're just going to know that when you do enter first number, that's going to be 2 different things. That you're going to print a message and then you're going to use the word input, right? So let's paste the results of our stuff from our code here as sample code to help you out. Sample code in class. And so our assignment. Using the following pseudocode. Alright, I think that's good enough. So the next thing this talks about is the idea of flowcharting. And I'm not going to hit flowcharting for a little bit longer. Those who took 1.1.13 have had way too much of flowcharting. So, yeah. But the idea of a flowchart is that each symbol is a step of one or more functions that the program is going to do. Here, the pseudocode may have said input name, followed by the next line, output hello name. This is just the same thing in a chart form. Input name being put into a parallelogram and output hello name being put into a parallelogram. Or you can get more complex. I talked about an if statement. With an if statement, you have two choices. If it's true, you execute one bit of code. If it's false, you either do nothing, or if there's the word else, then you do another bit of code. All right, that is actually about enough. Let's make a Dropbox for what we did in class. We will upload that, and we will call that a day. All right, if you refresh your Dropbox, you'll see in class B, it says Jan23.py, whatever you named today's script. Just go ahead and upload it into there. And I'll make one for the homework as well.